All right, so this is the notes for Math 3, Unit 2, Objective 1. So we will be analyzing piecewise defined functions. So before we get started, there's a few definitions that we need to go over. So the first one is, what does it mean for a function to be increasing? So a function is increasing when the y values increase as x increases. So this is kind of an intuitive idea. So what does it mean for a function to be increasing? What would it look like for that? So what we look at is just, are we going uphill as we move from left to right? So the x increasing meaning we're going from left to right, the y values increasing meaning we're going uphill. So if we have a function that looks like that, that would be an increasing function. And if we have a function that looks like this, that is still an increasing function. So one of the most common mistakes students make is they pay attention to arrows, and it really has nothing to do with arrows. So I could put something like that, and so we say, oh, it's going down because I have a downwards arrow, but the function is still increasing. So again, we try to ignore the arrows, so don't pay attention to the arrows. Just look to see, as we go from left to right, is the graph going uphill? Okay, so both of these would be pieces of functions that are increasing regardless of the direction of the arrow. Okay, so the second thing we take a look at is decreasing. So decreasing. So a function is considered to be decreasing on an interval when the y values decrease as x increases. Okay, so the y values are going downwards, right? So that means going downwards, provided your x values are increasing. And really, again, that part right there just means we are moving along the graph as we go from left to right. So again, whenever we see that x increasing, it just means that move from left to right whenever you read a graph. So again, so what would decreasing look like? So your decreasing function, okay, would be just meaning you're going downhill, but we know we're going downhill, again, as we go from left to right, okay? So again, so if I draw something that looks like that, that is a decreasing function, regardless of where I put arrows, right? So if I put an arrow here, I put an arrow here, even though this arrow is pointing upwards, this is still a decreasing function, right? So what does that mean again? We ignore the arrows, right? We don't pay attention to the arrows to determine increasing and decreasing. We pay attention to that line right here, right? So this line right here is what matters, not what those arrows are doing. So as we go from left to right, are we going downwards? As we go from left to right, is the line going downwards? Again, ignoring the arrows, okay? All right, then the third definition that we're going to be working with is, what does it mean for a function to be constant? So a function to be constant means that the y values have to stay the same, right? So the y values staying the same, meaning that they are all the same, like y equals 2, y equals 3, they will not change. And so what does constant? Constant just means it's going to be horizontal, right? So constant meaning horizontal, okay? And again, there can be an arrow pointed to the right, there could be an arrow pointed to the left, or even maybe on both sides, right? It doesn't matter. So that would be what we would call a constant function. So it would be horizontal, right? So that is horizontal, just as a reminder that that's what horizontal looks like. Okay, so side to side. Okay, so what is the definition of relative maximum? Okay, so our relative maximum, so this is our kind of what we call an algebra definition. So there's actually, so when you take calculus in a year, or I guess in a couple of years, you would get a different definition or a more solid definition of what a relative maximum is. So for us, we're using what we call an algebraic definition. So when do we have a relative maximum? So a relative maximum occurs at a point, right? So like an ordered pair, at which the function changes from increasing to decreasing. So that is very specific, right? So we have what we call a relative maximum when the graph goes from increasing to decreasing, and it occurs at that particular point. And that's when we have a relative maximum. So we have to go increasing, and then we have to go decreasing, right? So this would be increasing because we're going uphill as we read from left to right, and then downhill. So this dot right here, that would be the point at which the function changes from relative minimum to, from increasing to decreasing. So that dot right there, that would be a relative maximum. So if we have something that we go up, and then we go constant, and then we go down, then this would have no relative maximum here. So this would no relative max. And that's because there is not a single point, right, where the graph changes from increasing and then to decreasing. It's lots of points are happening, right? It takes a long time for it to switch. So it has to be an immediate change, not a slow change, like where we go increasing and then we level out and then decreasing. So this would have no relative maximum, right? So the graph did go from increasing and then eventually to decreasing. So this has no relative maximum, but this one does, right? Why is that? Because there is a single moment in time where the graph switches from increasing to decreasing, okay? All right, and then relative minimum. So let's take a look at our last definition here. So this is our last one. So what does it mean for a graph to have a relative minimum? So again, it's going to be a point, so a particular point, right? One point, one moment in time, at which the function changes from decreasing to increasing. So the flip, right? So the reverse of our last definition. So it has to go from decreasing to increasing. So when the graph goes down, that would be decreasing, and then right away switches to increasing. So that would give us a relative minimum. And so this would be a relative minimum. So one thing I should have pointed out at relative max, but I didn't, is I made this like look like, ooh, a sharp turn, right? That doesn't have to happen. It could actually be, you know, more of a parabola shape, quadratic shape. And so again, there is a particular moment in time where there is a switch from decreasing to increasing. So there's a relative minimum that could look like that as well, right? So it doesn't have to be a quick, sharp whoop, whoop. It could be a slower change on the slope of this line, right? Where it goes decreasing and then to increasing. So there is a single moment in time. So it could be a smoother transition, right, instead of a jarring transition, to have a relative min. And that would be true for your relative max as well. That it could be our negative quadratic, where this would have a relative max as well. So these would both have relative maximums at that particular point here. And then these would both be relative minimums at that particular point there where it transitions. Okay? All right, so let's go ahead and take a look at a few examples here. So my advice would be, like, if you've got these definitions and they make sense to you, is that you are regularly pausing. Like, don't just like listen to me yammer on. You should pause and say, well, can I do this problem? Is it as easy as it seems? And so my advice is, if those definitions made sense to you, is go ahead and press pause and see if you can try this problem, and then resume play and see if you got your answers right, okay? All right, so here we go. So example 1, we are answering the following questions about what we call a piecewise defined function. So this is a piecewise defined function because it is made up of a quadratic, right, or a piece of a quadratic, and then a constant function, right? So it's two different functions pieced together. That's why we call it a piecewise defined function, okay? So two pieces defined together. All right, so here we go. So for part A, they want us to state the open intervals on which f is increasing. So the open intervals, let's make sure we understand what that means before we get rolling too far. So when we have an open interval, we are very specifically asking for you to use parentheses, right? So whenever we see that word open, so this part right here, we always want to use parentheses. Okay, and we are using parentheses, so open meaning it is exclusive, excluding the endpoint. So that's what that means. So exclusive meaning excluding the endpoints. So whenever we say to use open intervals, we will be using parentheses to define it. And then again, open meaning we are excluding the endpoints. And then the intervals, so this part right here can sometimes be confusing. So the intervals means we are using the x values, intervals. So our left value of x to our right value of x. So we're looking for x values only. And we always want to do our left x to our right x. Okay, so whenever we talk about open, what does that mean again? That means to use parentheses. Whenever it says to use an interval, and there may be more than one, right, because that plural there. So interval means only use the values of x, so don't look on the values of y. And you're going from the left value of x to the right value of x. So we are looking for where the function is increasing. And remember, what does that increasing mean? That increasing means that we are going uphill, right? So increasing, we are going uphill, okay, as we go from left to right. Okay, so let's go ahead and answer that question. So where are we increasing? So whenever I do that, I go from left to right. And how come I'm going from left to right? Because it says to do the intervals, right? So that's what that refers to. So intervals. So from left to right, when are we going uphill? So I'm going to look at this graph here, and I'm going to put my pencil on the farthest left section of this graph. So that would be right here, right? So that's that left interval. So, and then now I'm going to trace the graph, and as I trace it, I'm going to pay attention to when am I going uphill, when am I increasing. So I start right here, farthest left section of the graph, and as I'm tracing, am I going uphill? And I am, right? So I am uphill right here, so this section is increasing. So I'm just going to do an INC to mean I'm increasing. And then, so I'm increasing, and then I switch, and then now I'm decreasing, right? So then I'm going to put a DEC next to that, because now I'm decreasing. And then I am flat, right? So flat lines right here. And so that would be constant, so I'm just going to write con, okay? So again, what did I do? I put my pencil on the farthest left section of the graph, and I traced it, paying attention, am I going upwards or downwards? So I'm going upwards, so I'm increasing. And then now I'm going downwards, so I'm decreasing, and then I'm going flat or level, so then I am constant. So let's pay attention, okay? So what does that arrow mean? So that arrow, we're thinking, oh, it goes downwards, but that's on the y values, right? So it's going leftwards, right? Leftwards. Because again, intervals, we're looking at x's only. So this section right here is coming from negative infinity, right? Negative infinity. And then when do I stop increasing? I stop increasing at this ordered pair here. So that ordered pair is at, let me use a color for that so it stands out a little better. So this ordered pair right here is at -1 and then comma 3. But what do we use on intervals? We use x values only. So I'm going to cross off that 3 because I don't care that it's at y equals 3. I care that it's at x equals -1, right? We want the x value only there. And so then now I'm decreasing, and I stop decreasing right here at this ordered pair, which is at 1, -2, right? So that ordered pair is at 1, -2. But again, we don't use the y value, so I'm going to cross that off. And then when do I stop being constant? I never stop, right? Because it's pointed forever to the right, so it's going to go to positive infinity, okay? All right, so that was a whole lot of information to answer just part A, but I think that will help us with the rest of them as well. Okay, so state the open intervals, so we're going to use parentheses, on which f is increasing. So it's increasing on this section here, and again, I want to use only the x value. So this section right here is defined by negative infinity, and then until we get to this dot right here, but again, we just use the x value, so that would be -1. So that's where f is increasing, is along this section right here, from negative infinity to -1. Okay, so now for part B, we want to state the open intervals on which f is decreasing. So if part A made sense to you and you think, okay, yeah, I got that, you should be pressing pause right now and trying to do B on your own, okay? All right, so for part B, where is f decreasing? So it's decreasing on this section right here, and again, we want open intervals, so that means use parentheses, and then intervals meaning use the x values. So from this ordered pair to this ordered pair, the function is decreasing. So from this ordered pair, the x value is -1. And then to this ordered pair right here, the x value is +1. Okay? So from x equals -1, so that's the section right here, to x equals 1, that's the section right here. So from x equals -1 to x equals 1, the function is decreasing. Okay? And if you have not yet pressed pause to try these, you should definitely do it on part C. So if you haven't pressed pause, you should press pause now and try part C. Okay. So for part C, we want to state the open intervals on which f is constant. So open meaning we're going to use parentheses, intervals meaning we're going to use the x values. So where is the function constant? It is constant on this line right here. So I'm going to say, so from this ordered pair, which started at x equals 1, because that's all we're using is x values, and then it doesn't stop, and so then to positive infinity. And you don't have to put the plus there. If it's positive, that's implied, just like we don't have to put a plus here to say that's positive 1. Okay? So it would be okay if you put a plus here, right? Because that's certainly not wrong. All right, so then for part D, we want to state the domain and the range of f. So our domain, just a reminder on that, domain are the x values, right? So that is our values of x. And we always want to go from left to right. Okay. And then we also want to state the range. And when we do our range, those are our values of y. And then we always want to go from bottom to top. Right, so how low does it go to how high it goes? Okay, so this is a good review question for us, right? Okay, so state the domain. Let's start with the domain. So we're going to do that just to the side right here. So domain. So we want to look to see like what is the lowest it goes to and to the highest, right? So domain, domain left to right. So how far left does it go to how far right it goes? So domain left to right. So this is certainly helpful, right? Because we did this already ahead of time. So leftwards, so this arrow, remember, goes 2 directions always, right? If it's on this kind of a curve. So it always goes 2 directions. So in this one, it's going leftish and downish, right? So leftish and downish. So leftish, meaning the farthest left it's going to go is negative infinity. But it's also going downwards, so that means it's going to go down forever as well, so negative infinity. And then this arrow right here is not going 2 directions because it's not on a curve, it's on a straight line. So it's only going 1 direction, and that would be to positive infinity. So positive infinity over here. And then let's go ahead, and so we have infinities on 3 of the 4 quadrantals. So we are just going to look at this guy right here. So there's no arrow that's going upwards. So that must mean it stops, right? It doesn't go up forever. So we look for then where is that highest point. So that highest point looks like it's right here. And I crossed that y value off, and that was only because for intervals we didn't need it, but certainly for domain and range we do. So how high does it go? It does not go above 3. So the highest this would go would be 3. All right, so then our domain is the x-axis. So we're going from negative infinity to positive infinity. And then our range, so for our range, remember we go bottom to top. So bottom, so it goes from negative infinity, so I'm looking right here. And then it doesn't go above 3. So our range goes from negative infinity and then to 3. And then because this is a closed dot, so domain and range, it doesn't say open intervals, so we have to pay attention. So it actually goes up to 3, including 3. So because it includes 3, remember that's when we use our brackets. Okay, so that would be our domain and our range. Okay. All right, and then that was a review from last unit, yeah? All right, so for part E, we want to state the coordinates. So coordinates, meaning we want to do ordered pairs, right? So for this guy right here, we want to make sure that we give a value of x and a value of y. And we are looking for the relative minimum. And remember, your relative minimum is when the graph changes from decreasing to increasing, right? So relative minimum, decreasing to increasing. So if I look, because I labeled this already, the graph goes from increasing to decreasing to constant. So there's no place where it goes decreasing first and then increasing. So that means there are no relative minimums, right? So there are none, okay? So none. All right, what about relative maximum? So relative maximum, so again, they want a coordinate, right? So whenever they want a coordinate, they want an x value, and then they want a y value. And so in order for us to have a relative maximum, that definition is when the graph changes from increasing to decreasing. So if we look at our graph up here, so our function, it's going from increasing to decreasing, and that occurs at this ordered pair or coordinate, so this right here. And so we have to give the x and the y value. So that would be at -1 and 3. Okay. So remember, this is an ordered pair, so this is the x and this is the y. This is not interval, even though it looks exactly like if you look up here at part B, right, the notation. So really make sure that when you look at something like that, it's always in context to the question. So in this case, it says intervals, so these are both x values. In this case, it says coordinates, so that's an x and a y. Okay? All right, and then one more example. And so if you think you are good and it makes sense, you should press pause, try it, and then when you're done trying it, is just watch the video to see if you got the right answers, and you can kind of skip ahead or increase the speed to figure that out. Okay? All right, so again, I'm going to trace the graph and just kind of label things like increasing, decreasing, that sort of thing. Okay? So again, I always start at the farthest left of the graph, so the farthest left section is right here. So I'm ignoring the arrow right now, and I'm just kind of following along here. So when I start right here and I start tracing the graph, I'm going downhill. So if I'm going downhill, that means I'm decreasing on this section. So I'm going downhill, downhill, downhill. I stop going downhill at this ordered pair, so that would be at -2, -3. And then I am now going uphill, so that means I am now increasing on that section. And then I stop increasing at that ordered pair, so that would be at 0, 1, so that guy right there. And then now I'm constant, right? So I'm constant again. And then I stop going constant at that ordered pair, so that would be at 2, 1. And then now I'm going decreasing, so decreasing right here because I'm going downhill. And then I stop decreasing at that ordered pair, so 4, 0. And then I start increasing right here. And I don't ever stop increasing, right? So that would be infinity there. Okay. All right, so then now for part A, it's asking for the open interval. So open, remember, we're using parentheses. Intervals, we're using x values only, right? So open, right, parentheses, and intervals, we're using the x values. And we're looking for where are we increasing, so we can look at what we have, because we already labeled it, right? So I said decreasing on this section, increasing here. So this section I'm increasing, so if I start increasing here, so again, we're using our x values, right? So make sure we're paying attention to the fact that we're using the x values, and then I'm still increasing to that x value there. So increasing, so started at -2, and I ended or stopped increasing at x = 0, okay? So again, we're not using the y values, right? When we do intervals, we only use the x values of the ordered pairs. Okay, and then if I'm looking here, I'm increasing again one more section, right? So again, we're paying attention to x values, so I'm going to ignore that 0, and I'm only looking at the x values. So I'm increasing one more section, so I'm going to use a union symbol, meaning there's one more answer, right? So from here, so this increasing section started at x = 4, and then it did not stop. It went till we got to infinity. Well, not that we got to infinity, but hopefully you know what I meant on that. Okay. All right, so let's take a look at part B. So for part B, we want to see where we decreasing. And again, we're using open intervals, so x values only. So decreasing, if I look here, I'm decreasing on this section. So this arrow, I'm going 2 directions, right? Always 2 directions on any arrow if it's on a curve. So the 2 directions I'm going is pointed upwards, right? So pointed upwards meaning we're going to positive infinity in the upwards direction, but it's also kind of going leftish, right? Not very fast, but it's going leftish. So leftish meaning negative infinity here, right? Negative infinity because leftish. So then from here, so for my decreasing, I'm taking a look at this section. So it's forever going leftward. So that would be from negative infinity. And then it stopped decreasing at this ordered pair, but I'm only going to use its x value. So that would be from negative infinity to negative 2. And then I had one more section of decreasing, and that's this one right here. So again, we're only using x values. So it started decreasing at x equals 2, right? We're ignoring that y value. So it started decreasing at this ordered pair, but use the x value, and I'm going to use that union symbol again. So it started at 2, and then it stopped decreasing at this ordered pair, but again, we're just using the x value. Okay. And there was no more, right? That was it. Okay. So for part C, so state the open intervals on which f is constant. So it is constant, only one section, and that's the section right here. So it became constant at this ordered pair, but only use the x value, so that would be 0. And then it stopped being constant right here at this ordered pair, but again, only use the x value. All right, so domain and range. So I have these two sections here labeled, and so I want to label this one as well. So this one was to positive infinity, so pointed right forever. So we'll go positive infinity here. And then there's no downwards arrow, right? So we have these three with infinities labeled, but we don't have an infinity down here. And that's because there's no arrow pointed down. And so that means it stops somewhere, right? It doesn't go down forever. So I need to figure out, well, what's the lowest section on this graph? And that would be this guy right here, right? So this is my lowest point, but we're labeling the y-axis, so I'm going to be using that y value right here. So this lowest part of the graph is to negative 3, okay? So that gives me all 4 sections, 4 branches there labeled, so that helps me with my domain and range. So remember, domain is your x-axis, right? So it's going to be these two guys here, left to right. And range is your y-axis, so it's going to be these two guys right here, bottom to top, right? So bottom to top. So my domain, so because we're doing infinity, and then let me zoom out just a little bit here so you can see what I'm writing. So for our domain, so left to right, and we're using infinity for both, so then we're going to have parentheses, right? Because you can't actually include infinity, so they would both be parentheses. And then now for the range, so the range is the y values. So for that, we're going bottom to top, so negative 3, and it's a closed dot there, so we would use a bracket, and then up to the top, and so that would be to positive infinity. And remember, I could put the plus there. I don't have to, but I could. And then because it's infinity, we'd use parentheses. So if the domain and range is confusing you and you're like, oh, I don't remember doing that, that was in Unit 1. So you can maybe go back and look at your notes for Unit 1, or maybe watch one of the videos again just to kind of jog your memory on domain and range, since I kind of am skimming over that a little bit. Okay? All right, and then let's take a look at part E and part F. So for here, we want to find the coordinates. So remember, whenever we talk about coordinates, that's different than intervals, right? So coordinates are a single point, an ordered pair, so we need an x and a y value. And we're looking for my relative minimum. So my relative minimum is where does the graph switch from decreasing to increasing. So when I look at my graph up here, I'm decreasing and then I'm increasing, and that switch occurred down here, right? So I decreased, then I increased, and that occurred at that ordered pair right here. So because it's a coordinate, then we are using an x and a y value, so that happened at this ordered pair, negative 2, negative 3. And then I'm going to keep looking, because I'm going to look for all of them, right? So then I'm increasing to constant, so that's nothing. Constant to decreasing, nothing. And then decreasing to increasing, so that occurred right here, right? So decreasing to increasing, and that switch occurred here. And again, because I want coordinates, I need an ordered pair. So there would be one more, right? So not just at negative 2, negative 3, but there's another one at 4, and then 0. So sometimes that's confusing to students because They're like, well, wait, why is there two relative minimums where this is the lowest point? And it's because a definition of relative minimum doesn't mean the lowest point on the graph. It means where does the graph switch from decreasing to increasing? And that happened twice, so that's why there's two relative minimums. Okay, so then the last one right here, so this is the last part. We want the coordinates. So again, what does coordinates mean? So different than interval, that means we want an x and a y. And then we're looking for the relative maximum, right? We're looking for that relative maximum. So maximum, remember, is when we are switching from increasing to decreasing. So if I look at this graph here, I'm going decreasing and then increasing, right? And then here I'm going increasing to constant. That doesn't count, right? It's got to go straight away at one order pair, increasing to decreasing. So that's nothing. Constant to decreasing is nothing, right? And then decreasing to increasing is that minimum. So in this problem then, there are no relative maximums, okay? And that's it for Objective 1, Unit 2.